Now in class 11th, I am taking the topic motion of the vehicle on the banking road. So first we have to understand that what is the meaning of the banking road. The such roads are made on the hill area or the hill stations because the hills are just above the earth's surface, so they having the circular roads, and for the safety for the vehicle, the outer part of the road is elevated with the horizontal, that it makes some angle with the horizontal. Then this angle is called the angle of banking. The banking roads are made on the hills or the circular turn. The outer part of road is slightly raised up, making an angle theta with the horizontal. With the horizontal, it is called angle of banking. तो ये इस तरीके से होता है that suppose this is the horizontal, this is now surface, then what happens, this road is just elevated. It's just elevated. Then this angle theta, this is called the angle of banking. Let this is now length of this road, this is now suppose B the width, this is raised to height h, then this angle theta. So tan theta equal to h upon b. H upon b. B the width, where b equal to width of road. H, this is now has been the outer part. This outer part has been lifted to a height of h. So this is now, suppose initially it was now AB, then now it becomes AB dash to AB dash. This is the banking road. AB dash. AB dash is the banking road. Banking road. So now let's M equal to mass of vehicle and V equal to velocity of vehicle moving on a banking road of radius r, and let mu is the coefficient of friction. Mu equal to coefficient of friction. So now let us have the forces. Forces acting on the vehicle. Which are these? Number one, the weight. Ng. This is vertically downward. Vertically downward. Second, the frictional force. Friction force. F. Fr. So this is tangential between road and wheels, and third is normal reaction. Vertically upward. Upward to the vehicle. To the vehicle. And number 4, centripetal force. Fc towards center of circular road. Circular road. So let us show all these forces on the vehicle. This is suppose the horizontal. This is now suppose the road that has been elevated. The outer part, this is now H. This is suppose A, B. This is now A, B dash. Sorry, this B dash. B dash. This is the angle of banking. Let this is the vehicle. Suppose this we are having a vehicle. Then what the normal action will act vertically upward to this vehicle. So this will be like this. This is now R. If this angle is theta, then now here we will have a force. This is what? The weight mg. Weight mg. Then the frictional force. The frictional force will act in this direction. This is now your Fr. This is what? Fr, the frictional force. The centripetal force that will act in this direction. This is what? Fc. So now if we draw a line just opposite to this weight mg, then it will make some angle. Let this angle is also be theta. If this angle is theta, then this is also theta by geometry. So this is your R cos theta. V component to this one, this is like this. This is your R sin theta. Similarly, if this we take the frictional force F, then this will have again the components. This angle will be theta. So we will have this component to be Fr this cos theta, and this will be your Fr sin theta. These are the components of this frictional force and the rational force. We can have the components. Components of R. That is now you this R cos theta and this R sin theta. Similarly, the components of Fr. Fr. This is now your Fr cos theta and Fr sin theta. So now you can see that I have shown all the forces. This is a normal reaction, this is now weight, this is now frictional force, this is now centripetal force. So now what we have? In equilibrium, these two forces will balance to this one. It means that this centripetal force will be provided by both the frictional force and the normal reaction. And here the resultant of this R cos theta and Fr sin theta, that will give you the weight. So the equation of motion of this vehicle in equilibrium. What we are having? This R sin theta plus Fr cos theta, this is equal to mv square upon r. This is now your Fc. mv square upon r. And this your R cos theta minus FR sin theta. This is equal to mg, the weight. Resultant of this force and this force will give you mg. Resultant of these two will provide you this force, the centrifugal force, mv square upon r. So if we divide, this is now suppose equation number 1, this is now equation number 2. Dividing equation 1 by 2. 1 by 2. So what we are having? That is mv square upon r into mg equal to r sin theta plus fr cos theta upon r cos theta minus fr this sin theta. So now what we have, this m and m will cancel. So this is now your v square upon r. Now what we have to find? We have to find the velocity that by which the vehicle can move safely on the banking road. And this we can write to this now r tan theta plus mu r upon r minus mu r tan theta. We have divided the numerator and denominator by cos theta. So this term will come out, and in place of fr we have written down this mu r. Fr is equal to mu r. So now this r will cancel from all these. So b square upon rg equal to, this is your tan theta plus mu upon 1 minus mu tan theta. And we can have this b equal to rg into tan theta plus mu upon 1 minus mu tan theta. This is now square root of so much. This is the velocity. Now you can see from here that this is the maximum velocity, because this factor is minimum and this factor is maximum. So because of that, this b is maximum. It is maximum velocity. It means what? That this b maximum is equal to square root of rg into tan theta plus mu upon 1 minus mu tan theta. Then what will be the minimum velocity? For minimum velocity, this factor must be minimum and this factor must be maximum. So in place of minus, this will plus, this will have the minus, and here in place of minus we will have the plus. So V minimum equal to square root Rg into tan theta minus mu upon 1 plus mu tan theta. This is the minimum velocity. Then what about this? The mean average, the average velocity. Average velocity. This B bar is equal to B maximum plus B minimum upon 2. So you have seen that on the hill stations the speed is written on the side of the road, that is 30 kilometer or 40 kilometer per hour or 20 kilometer per hour, like that. That is the safe velocity. This is what that the average velocity. You cannot have the velocity more than that. If you do so, the vehicle will take a turn towards the away from the center, and this will skid. And if suppose we are having the velocity less than this one, you can move safely. So either you have the velocity that is equal to the that is prescribed there, or the velocity less than that one. Only then you can move safely on this banking road. So now this we take the equation number 3. It is safe velocity by which the vehicle should be moved on the banking road. Banking road. So now what we have? Now if suppose we take this from equation 3. From equation 3. If suppose this mu is equal to 0, if mu equal to 0, this means there is a frictionless road, then what will happen? This B equal to square root of Rg tan theta. This I have told you earlier. For the plane road, this tan theta is equal to 1. And second, if tan theta is equal to 0 degree, is equal to 0, then V equal to square root of mu r. So tan theta equal to 0 means this will be 0, this will be 0, so only mu is left here, then this is equal to so much. So when you are given the plane road, then the velocity must be equal to this or less than this. So for say, so V should be less than equal to square root of mu r. This is the required condition for safe moving on the banking road. So though this is the part of the circular motion, but I have told you here because we are concerned with the friction. So this is what that the velocity must be minimum that is required for the safe turn on the banking road or on the while taking a circular turn either towards left or towards right or towards the left. So this is written on the upright board that this speed must be of the vehicle, so must be equal to either this 30 km per hour or 40 km per hour or 20 km per hour. So this is only for the safety of the vehicles and all the human beings which are moving along with their vehicles. So this is so many times the question is asked that what should be the condition for this one when the vehicle is moving on this banking road or the circular road. So thank you very much.